Let's look at the solution to the 2023 JAMB Physics examination questions. Question 1 here says, a parallel plate capacitor has its plate maintained at a potential difference V. Introducing a dielectric material between the plates will effectively A. Decrease the charge on each plate, B. Increase the charge on each plate, C. Leave the charge on each plate unchanged, D. Decrease the capacitance of the capacitor. So which of these is the answer? Now recall that when it comes to charge and potential difference, the formula that relates them is simply Q, that the charge Q is equal to C, the capacitance, times V, the potential difference. You have this. Now for this question here, you also want to note that when we introduce something called the dielectric material, right, each dielectric material has a constant known as the dielectric constant. And for this particular question there, you want to note that introducing the dielectric constant into this equation, you have that Q is equal to K, where K is the constant of the dielectric material, also called the dielectric constant, times CV. In essence, if the value of CV was 3 and the dielectric constant was 1, you have that Q is equal to K, that's 1, times CV. CV is 3. This will give you what there? 3. If I increase the value of the dielectric constant, let's say we have a second example where K is 2, you have that Q is equal to the electric constant. Let's take the value as 2 times, we said we should take the value of CV as 3. 2 times 3 is 6. From here, what do you observe? Observe that as the dielectric constant is increasing, well, for different material, the value of the charge also increases. So what does this mean? It means that the value or the correct answer here would be what there? B, which means it will increase the charge on each plate. And this is true because dielectric constant is directly proportional to what there? Charge. So as the value of the dielectric constant increases, the value of the charge also increases, as I have illustrated here. All right, question number 2. Question 2 says, which of the following is an essential physical property of the wires used for making fuses? A. Low density, B. Hypothermal conductivity, C. Low electrical resistivity, D. Low melting point. Now, for this question, you want to note that when we talk about a fuse, all right, a fuse must melt easily when excess current flows, all right. The idea of a fuse is that whenever you have excess current flowing through a particular circuit, the fuse is supposed to melt. And for a fuse to melt, it means its boiling point has to be low, such that when high current is passing through it, it will melt. In essence, for this question, the correct answer is D. It has to have a low melting point, such that when high current passes through it, you have that the fuse will melt. So the fuse should have a low melting point. That's your answer. All right, question number 3. It says a boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. If the speed of sound in air is 3.40 meter per second, how far is he from the hill? A. 66 meters, B. 1.36 meters, C. 264 meters, D. 528 meters. Now, how do you solve this question? In the question, you're asked to find how far is he from the hill. So when we talk about how far, what comes to mind is distance. For this question, question number 3, you're given velocity v of sound in air as 3.40 meters. All right, so that becomes 3.40 meters per second. That's velocity of sound in air as given in the question. They said for 0.8 seconds, that's the time. All right, so the time, the t, is equal to 0.8 seconds. You have to find the distance, how far. Let's call it this. Let's call this a capital D. Okay. Distance is capital D. Now, from the kinematics, we know that velocity V is equal to D all over T. All right, that's displacement all over time. We know this. Now, from this given equation, you want to note that this question is on echo. And for echo, we said, let's say the boy is at this point here, all right, and he claps his hand. So this is his leg, and he claps his hand like this, all right. He produces a particular sound waves such that they said receives by nearby hill. All right, so let's get the hill here. Okay, let me draw this better. Let's get this. So let's call this the hill. Let's call this the hill. Now, what you observe is that when this boy claps his hand, right, the sound waves moves from this point here, from his hand, goes to the heel. It covers a distance, small d. Now, for this boy to hear that sound, this heel must reflect this particular sound wave back to him. So you have another d. In essence, the total distance traveled by the sound wave is equal to the d moving from the boy to the hill, and then the second d, so plus a second distance of this sound traveling from the hill back to the boy. All right, so it becomes d plus d. In essence, the total distance is equal to 2d. So for echo, you want to note that velocity v is equal to 2 times distance. Very important, all over time. So you have this. In essence, to find the value of distance, you multiply this all over 1, so it becomes v times t. 2d times 1 gives you 2d. So you have that 2d is equal to vt. From here, you can have d as being vt divided by 2. Of course, to get the value of d, let's come back to this. To get the value of d here, divide by 2, divide by 2. This cancels this. So d is equal to vt all over 2. Put in value. What's the value of v? V is 3.4. That becomes 3.4 times t. T is 0.8. This all over 2. Let's bring in values. That becomes 3.4 times 0.8 all over 2. The answer here is 1.36. 1.36 in meters. That's your value. So let's see if we have that value here. Yep, we do. That's option B, 1.36 meters. So that's how you solve that question. Question 4 says, when the surface of a piece of chalk is scraped, the tiny particles that flick off are known as A. Matter, B. Molecules, C. Elements, D. Atoms. Now you want to know that the first thing for this question here, what's the correct answer? Of course, it cannot be matter, because for anything to be considered matter, two conditions. Number one, it must have a mass. Number two, it must occupy space. Now, for the tiny piece of chalk, its mass is usually negligible. So the mass is literally nothing. All right, so we could say it is massless. So since it is massless, it cannot be matter. So A cannot be the answer. If you look at D, when it comes to, okay, let's look at C. C says elements. Of course, that's not an element. You want to know that chalk is made up of calcium trioxocarbonate, that's CaCO3. All right, what you have here is a compound, not an element. So it cannot be elements. If you look at this is actually a molecule. The correct answer there is B, molecule. It's a molecule, all right? A molecule of calcium trioxocarbonate 4. It cannot be atom, D. D cannot be the answer. Why? Because it's from this molecule of chalk or a tiny chalk, CaCO3, can be broken down into smaller atoms, all right? And when we break this down to atoms, that's why you now have an atom of calcium combining with an atom of carbon, combining with 3 atoms of oxygen to give you that molecule. So what you have there is just a tiny molecule of chalk, not atoms, not matter, not elements. All right. All right. Question number 5. Which of the following is not a product of nuclear fusion? A. X-ray, B. Gamma ray, C. Alpha particles, D. Neutrons. For this question number 5, you want to know that the correct answer there is C. Alpha particles. Now, here's what to note. Alpha particles are products of radioactive decay and not necessarily fusion directly, all right? Now, you know that if you look at some text and some authors will say one of the products of nuclear fusion should be alpha particles. But if you study this critically, right, study this critically, you will note that alpha particles are actually the product of radioactive decay and not necessarily nuclear fusion directly. So the answer there is alpha particles. That's your answer. All right, next question. Question number 6. Question 6 says a 500 watt heater is used to heat 0.6 kilogram of water from 25 degrees Celsius to 100 degrees Celsius in T seconds. If another 1000 watts heater is used to heat 0.2 gram, this is supposed to be kilogram, right? 0.2 kilogram kg of water from 10 degrees Celsius to 100 degrees Celsius in, this would be T2, not T squared, right? In T2 seconds, fine, this will be T1 over T2. T1 is the time for the first par. T2, subscript 2, or not par 2, is the time for the second par. So find the ratio of T1 to T2. So it should have been T1 all over T2 like this, okay? A, 50, B, 5, C, 100, D, 1 over 3. Now, how do we solve this question? To solve this question here, the first thing you want to do is that you want to get your equation for par. They say watt, and watt represents par. Now, you want to note that for this case, question number 6, that par, let's call this par, P, the formula that relates that, right, is simply M mass times C, where C is the specific heat of the liquid, which in this case is water, into change in temperature, that's change in T, all over, so this divided by T. So you have this, all right, change in temperature, and just to divided by time, as you have this, and just to differentiate between this T into change in temperature, capital T, all over time, all right? That's pi is equal to work done all over time. That's the concept there. Now, they mentioned two heaters there for question 6. They mentioned 500 watt heater. So let's call for heater 1, for heater 1. So the power, let's call it P1, is equal to 500 watts. So you have that P1, the same formula here, P1 is equal to M1 C, right? Specific heat of water is a constant, so there's no C1, it's just C, into T2 minus T1. You have this T2 minus T1, this divided by time 1. That's this, all right? Let's put in values. The value of P1 is 500, so 500 is equal to, what's the first mass in the question? In the question they said 0.6 kilogram. That's the first mass. So M1 is 0.6 into C. The value of C was not given, so we'll take it as C. There was a change in temperature. They said from 25 degrees to 100 degrees Celsius. So the second temperature is 100 degrees Celsius. The first one is 25 degrees Celsius. So it becomes 100 minus 25. This all over T1. The value of T1 is not given. Take this as all over T1. Now let's get this done. If we solve this, this becomes 500 is equal to 0.6 C into 100 minus 25, and that value there is simply 75. So 75, this all over T1. So from here you have that 500 is equal to, you multiply this, that's 0.6 times C times 75. If you do that, you have all of this as 45C. So you have 45C. This is all over T1. So divided by T1. From here, this can cross multiply. This is all over 1. So this times this, 500 times T1 gives you 500 T1. It's equal to 45C times 1 gives you 45C. Let's call this our equation 1, right? So this what we have here is for heater 1, where the power was given as 500 watts. Let's get for heater 2. Let's get for heater 2. So for heater 2, for heater 2, the power there, P2, was given as, let's check again. What's the power for heater 2? The value there is 1000 watts. The mass is 0.2. All right, so P2 is equal to the same formula, M2C. So I'm having M2C into change in T, right, all over T2. So we have this. So P2 is 1000. So let's take the value of P2. P2, as seen in the question, the second part there is 1000 watts, M2 is 0.2 kg. So P2 is 1000 is equal to M2 is 0.2 times C, specific heat of water, then change in temperature. For this case, it was from 10 degrees Celsius to 100 degrees Celsius. That becomes 100 minus 10. That's a change in temperature divided by T2. The value of T2 is unknown. From here, we have 1000 is equal to 0.2 C. 100 minus 10 is 90 all over T2. From here, you have 1000 is equal to 0.2 times C times 90. 0.2 times 90 gives you 18. So you have 18. Bring the C down. So C, of course, divided by T2. So all over T2. From here, we can cross multiply. This is all over 1. This times this. 1000 times T2 is 1000 T2 is equal to 18C times 1 gives you 18C. Call this equation 2. In the question, we are asked to find the value of T1 all over T2. So how do you get the value of T1 over T2? Now, looking at what I have, you can see that T1 exists in equation 1 and T2 exists in equation 2. So I'll divide equation 1 by equation 2. For equation 1, I have 500 T1. So 500 T1 is equal to 45C. So 45C, all divided by for T2, I have 1000 T. So 1000 T2 has been equal to 18C. So being equal to 18C. From here, you can see that this will cancel this and it's off, right? 0 cancels 0, 0 cancels 0. 5 here, 1, 5 here, 2. So working on this, 1 times T1 numerator, you have T1 all over 2 times T2 is 2T2. It's equal to 45 all over 18. Now, to eliminate the 2 attached to T2, all you have to do is multiply this by 2, multiply this by 2. Now, you might want to say, what if we cross multiply? Well, that still works, okay? You have the same answer. For this 2 cancels 2, we're having that T1, we're having that T1 all over T2, I'll write this better, all over T2 is equal to 45 times 2 is 90, so 90 all over 18. 90 divided by 18, the value there is 5. So the final answer there is 5. So let's see if you have 5 as one of the options there. For this question, the answer is B, right? Option B, 5, is the correct answer. Okay, let's look at the next one there. Question number 7. Question 7 says, what is the total electric energy consumed by using an electric cooker rated 100 watts for 5 hours? You have option A, option B, option C, and option D. Now, how do you solve this question? For this question here, you ask for electric energy. Number 7, to find electric energy, what do you do? So, electric energy, all right? Electric energy. Now you want to know that power P is equal to work done or energy all over time. You have this, all right? Energy over time. In essence, from here, if I cross multiply energy times 1, energy is equal to P times T. That's power times time. In essence, the energy E is gotten by multiplying the power. The power, we're using the value in watts, which is 100. So 100 times the time. We'll convert the time to seconds. The time is 5 hours. Convert 5 hours to second. You multiply 5 by 60 times 60. All right. So this is how to convert the time. This is time in seconds. All right. So let's multiply this. So from here, the energy E is equal to, becomes 100 times the time in seconds, 5 times 60 times 60. And that's about 1.8 million. That's 1800123. Energy is in joules. In index form, this is 1 point. Let me write this better. In index form, this is 1.8 times 10 to power. From here, we have 1, 2, 3, 4, 5, 6 to power 6 joules. 1.8 times 10 to power 6 joules. That is option C. So option C is the correct answer. All right. Question number 8. Question 8 says the critical angle for light traveling from a transparent medium to air is measured as 34 degrees. The refractive index of the medium is A 0.56, B 1.50, C 1.79, D 2.02. So how do you solve this question? For this question here, if you look at this, they said the critical angle for light, all right, traveling from a transparent medium to air is measured as 34 degrees. So you're giving critical angle C as equal to 34 degrees. That's for question 8. So for question 8, you're given that critical angle C is equal to 34 degrees. And you're asked to find what's there. You're asked to find the refractive index. Note that when given critical angle, refractive index N is equal to 1 all over sine C. All right? Please note this formula. From Snell's law, we know that N is equal to sine of the angle of incidence all over sine of the angle of refraction. We know this from Snell's law. But in this case, we're not using Snell's law, we're using critical angle. And if you're working with critical angle, N is equal to 1 over sine C. That means N, refractive index, is equal to 1 all over sine of 34. So just pick up a calculator or punch this, 1 divided by sine 34. If you punch this, your answer is 1.788 approximately, 88. And when you approximate this, you have your answer as 1.79. So your answer there is 1.79, which is option C. So option C is your correct answer. All right. So question number 9. Number 9 says a platinum resistance thermometer has resistance of 5.25 ohms and 9.75 ohms at 0 degrees Celsius and 100 degrees Celsius respectively. When the resistance is 8.25 ohms, the temperature is A 63.6 degrees Celsius, B 66.7 degrees Celsius, C 75.0 degrees Celsius, D 84.6 degrees Celsius. Now, how do you solve this question here? Now, for this question, number 9, we'll have to draw a thermometer with reading. All right, just a simple diagram sketch. I'm going to come here, I'll draw this, and I'll put this as top 1, this as bottom 2 or middle, and this as bottom 3. The first thing they gave there, they said has resistance. I'll put the resistance value here. Let's put resistance value here, this, and I'll put the temperature degrees Celsius value here. Nope, let me take this back. So I'm going to put the resistance value here. I'll put the degrees Celsius value here. All right. The first thing we have, they said 0 and 100 degrees Celsius. Okay. So I'll come here. I'll put 0 at the bottom. I'll put 100 degrees Celsius. The values were 5.25 ohms and 9.75. So 5.25 and then 9.75. 9.75. So you have these two values. Okay, they said when the resistance is 8.25 ohms. Now 8.25, as we know it, is in between 5.25 and 9.75. So we have this as 8.25. All right, this value is in between this and this. All right, so they say the value of the temperature. Let's call this x. We don't know the value. So we have to find the value of x. Now, what you use here or what you do here is something called interpolation. All right. So something called interpolation. And how do you do that? Now, to find the temperature as x, so x, that's the temperature at that point, will be equal to, the first thing you do is that you take, take a ratio of, for x, what you have to do is you take the temperature at x, which is 8.25. So that's equal to 8.25 minus the datum, or the temperature that's the smallest, which is at 0 degrees Celsius, which is 5.25. So observe this. All right, to get the temperature for x here, you take the temperature as x, which is this, minus the datum temperature that's at 0 degrees Celsius. Now, for 100, so it becomes 100. We take the temperature as 100. This will be equal to, repeat the same concept. When we did x, right, for x, we took the resistance at x, 8.25, minus the resistance at 0 degrees Celsius, 5.25. Now, for 100, we'll take the resistance at 100 degrees Celsius, which is 9.75, minus, again, we use the datum. So we'll still work with the datum there, 5.25. All right, let's subtract these values. Subtracting this 8.25 minus 5.25, that's about 3. So 3 all over. Next up, 9.75 minus 5.25, that's about 4.5. So 4.5. From here, let's cross multiply. X times 4.5 gives you 4.5x is equal to 100 times 3 gives you 300. All right, 300 is just 100 from here times 3. All right, so 3 times this 100. So you have this. So x from here, to get the value of x, divide here by 4.5, divide here by 4.5. Excuse me, 4.5. This cancels this. So x is equal to 300 divided by 4.5, and that's about 66.67 approximately. 67. This is this was temperature. X was the temperature, so in degrees Celsius. 66.67 degrees Celsius. Do you have that value there? All right, so we have 66.7. It's the same thing. All right, this is 66.7 approximately. 66.7 degrees Celsius. That's your answer. So that means the correct answer there is B, 66.7 degrees Celsius. All right, one final question for this video. Question number 10. 10 says a body weighing 100 Newton moves with a speed of 5 meter per second in a horizontal circular path of radius 5 meters. Calculate the magnitude of the centripetal forces acting on the body. Take G, that's acceleration due to gravity, as 10 meter per second squared. A, 10 Newton, B, 50 Newton, C, 75 Newton, D, 100 Newton. So how do you solve this question? In this question here, we ask to calculate the magnitude of the centripetal force. All right. We know that centripetal force Fc is equal to mass times centripetal acceleration. From Newton's second law of motion, we know that F is equal to m times acceleration. When it comes to centripetal, it becomes centripetal force equal to mass. Mass is always constant, so there is no centripetal mass. Mass is mass. Then acceleration becomes centripetal acceleration. So we have this. Again, the centripetal force is equal to mass. Centripetal acceleration is given by v squared all over r. Right? So please take note that AC, centripetal acceleration, is equal to square of velocity all over radius. Let's impute values from here. So this is equal to the mass. The value of the mass is, oh, we're not giving mass, we're giving weight instead. Weight is 400 Newton. If weight is equal to 100, what is mass? Weight is equal to mass times gravity. The weight is 100 Newton, is equal to mass is unknown. They said take gravity as 10 in that question, as you can see here. Gravity is 10. From here to get mass, divide here by 10, divide here by 10. This cancels this. The mass m is equal to 100 over 10, which is what there? 10 kilogram. That's the mass. So Fc, centripetal force, is equal to the mass, which is 10 kilogram, into v squared. Squared of velocity, v is 5 meter per second, so it becomes 5 squared all over r. Let's take the value of r there. The value of r, part of radius 5 meters, becomes all over 5. This is equal to 10 into 5 squared is 25 all over 5. And that's equal to 5 times 25 is 250. 250 all over 5. From here, we'll have that centripetal force Fc is equal to 250 over 5. The value is simply 50 in Newton. So the value of the centripetal force is 50 Newton, which is option B. So option B is the correct answer. All right. Question 11 says, a boy travels 8 kilometers to a point B and then 6 kilometers northwards to another point C. Determine the difference between the magnitude of displacement of the boy and distance by him. A, 2.0 kilometers, B, 4.0 kilometers, C, 10.0 kilometers, D, 14.0 kilometers. So how do we solve this question? Now for this question, question number 11, all right, question 11, they said the boy travels to a point B, 8 kilometers, and then they said 6 kilometers northwards. So to point B, we are not sure if it's towards the east or towards the left, but then let's take towards the east. So let's call this point a starting point S. So it moves from S towards B, that goes this way to this point here. Let's call this B. And they said for B there, the distance covered is 8 kilometers. So we have 8 kilometers. Next on the side, he traveled northwards, that's upwards. So northwards, upwards to another point C. All right, so point C. So perhaps we should call this A. So it becomes A, B, and C. All right. To point C, they said he traveled 6 kilometers. All right, for this question here, we are asked to find the difference. Where's the question? They said difference between the magnitude of displacement of the boy and distance by him. All right, so we're looking at the difference between his displacement and his distance. First things first, how do we get displacement? Let's get displacement. All right, how do we get displacement? You want to take note that displacement is equal to the distance from A to C. That's this distance here. That's his displacement, all right, from A to C. We'll call this displacement, let's call this D, all right? So distance from A to C, we'll call it displacement D. Now, to get the value of the displacement, all we have to do is to use Pythagoras theorem, because we can see that this is actually a right angle triangle, all right? So it means that to use Pythagoras theorem, square of the hypotenuse, d squared, is equal to the sum of the square of the other two sides. That becomes 8 squared plus 6 squared. From here, we'll have that this is equal to 8 squared is 64 plus 6 squared is 36. And if you add that, 64 plus 36, you have your answer as 100. So 100. So that's equal to 100. So D will be equal to, or D squared is equal to 100. That means D will be equal to, we'll take square root. So square root of 100, and that's equal to 10 in kilometers. So the displacement is simply 10 kilometers. Next up, let's get distance. Now, to get distance, all we have to do is to sum up all the distances traveled. We'll call distance S. Now, S becomes from A to B, that's the distance or absolute value from A to B, plus the distance from B to C. That becomes absolute value of B to C. Let's sum this up. From A to B, here, distance is 8 kilometers, that's 8, plus from B to C, the distance is 6 kilometers, so it becomes plus 6. So 8 plus 6 gives you about 14. So I have 14 kilometers. If you're looking for the difference between the distance and displacement, right, that becomes 14, that's distance, minus displacement, that's 10. And if you subtract 14 minus 10, that gives you 4. This was measured in kilometers. So I have my answer as 4 kilometers. All right, so let's see which option that is. So looking at this, the correct answer is B, 4 kilometers. So that's your answer. All right, question number 12. 12 says, a cube of side 0.1 meters hangs freely from a string. What is the upthrust of the cube when totally immersed in water? Take the density of water as 1000 kilogram per meter cube, mass over volume, so it should be 1000 kilogram per meter cube, right, raised to power minus 3. And they say you should take G, that's gravity, take G, gravity, as equal to 10 meter per second squared. Your option A is 1000 Newton, B is 700 Newton, C is 110 Newton, D is 10 Newton. So how do we solve this question? So let's solve question 12. For 12, so question 12, you're given the side of the cube. Let's call it S, right, or let's call it length, one of the length of the cube as 0.1 meters. That's this. Next up, they said, hangs freely from a string. What is the upthrust of the cube when totally immersed in water? They give it density of water. So rho, density of water, rho of water as 1000 kilogram per meter cube. They give it gravity as 10 meters per second squared. You ask to find upthrust. So upthrust is equal to unknown. So how do you find upthrust for this question? The first thing you want to notice is that upthrust is a force that tries to oppose the weight of a body immersed in a fluid. So let me show you this quickly. Let's say I have a jar here containing liquid, and I have this particular cube. All right, I want to put this particular cube in this jar. I want to place this down here. Now, when you place this cube, right, bring this cube into this jar of water here. All right. When you put this cube here, what you observe now is that the weight of the cube acts downward. Now, when the weight of the cube goes downward, this liquid or this fluid here will try to produce a force that will act in the opposite direction of the weight that's going upwards here in order to oppose the weight of this particular cube placed in this liquid. Of course, this is accordance to the third law of motion, which says that every action must have an opposite and equal reaction. So the kind of force that this fluid would exert on this cube is called the upthrust. All right. So in essence, upthrust is simply a force that tends to oppose the motion of a particular material that is being placed inside a liquid, as you can see here. In essence, upthrust is measured in Newton. It's a kind of force. So upthrust technically is the same thing as a force, just a type of force. In essence, we're saying that upthrust is equal to a force. Also, from Newton's second law, we know that force is simply equal to mass times acceleration. All right, that's F equal to ma. Again, considering the concept of free fall, We said when a body is moving vertically, either vertically upwards or vertically downwards, we said that acceleration will be equal to what there? Gravity, right? We've discussed this in our previous class. So you can check our playlist, right? Check our playlist on JAMB classes. So go to playlist and then you see JAMB and post-UME classes. We've discussed these things in full, right? In full details. Here I'm only solving questions. So in essence, A becomes G. That's what we're saying, right? So A simply becomes G here. So we have this. So Upthrust is equal to mass times gravity or acceleration due to gravity. In this question, I have a value for gravity as 10, but I do not have mass. Again, we can recall that density rho is equal to mass all over volume. Of course, this is all over 1. So we can get this mass times 1 is mass is equal to rho times V density times what? The volume. We can get mass by multiplying density and volume. What's the value of density? We can see it here as 1000. So this is equal to density is 1000. What about volume? Were we given volume? The answer is no, but we can get volume from length. We know that volume V is equal to L cube. So if we cube the length, we get volume. Now we are cubing the length because this is a cube. All right. For a cube, all the sides are equal. So for a cube, the volume of a cube is simply equal to the length to power 3. That's it. Right. So it becomes volume here. That becomes L 0.1 to power 3. If you multiply all of this, 1000 multiplying 0.1 to power 3, if you punch this, your answer will give you 1. So it means that the mass is equal to 1 kilogram. In essence, the upthrust is equal to the mass 1 kilogram times gravity, which was given as what there? 10. 1 times 10 gives you 10. We said upthrust is a type of force, so it's measured in what there? Newton. So the answer there is 10 Newton. Let's see which option that is. That is option D, 10 Newton. So that's my answer. All right, next up, question number 13. It says the dimension for power is dash. You have option A, option B, option C, and option D. So which of these is a dimension for power? Again, we've discussed this question in our previous class on dimensioning. Now let's solve this question. For question 13, we know that power, to dimension any quantity, we must first of all define it. Power is simply work done or work all over time. Right? By definition, power is the rate of doing work. That means mathematically it's work over time. For work, right? For work there, the formula for work is simply force times distance. Force times distance, that's work all over time. That's this. So let's dimension this one after the other. Starting with force. Force, as we know it, force is equal to mass times acceleration. Now for mass, the dimension is capital M, that's for mass, times for acceleration, the unit is meter per second squared. All right, so when you have meter per second squared, meter is the unit for length, so length. Seconds is the unit for time, that's t. Of course, seconds is raised to the power minus 2, so it becomes minus 2. So this is equal to, for force, I have m L to the power minus 2 times distance. Distance simply represents length, that's L, all over, you have time, right? Time is a capital T, so you have T. All right, let's dimension this. This is equal to, if I multiply numerator, this becomes m into L times L gives you L squared into this one here, T to the power minus 2 all over T. Now working on this, this is equal to, this becomes ml squared T to the power minus 2. This denominator T can be written as T to the power minus 1. All right, so this becomes times T to the power minus 1. So to move anything from denominator upwards, just attach minus 1 to it. That's the concept. This is equal to ml squared T to the power. Whenever two things are multiplying, you add their powers. So minus 2 plus minus 1, or minus 2 minus 1, that gives you minus 3. So the answer there is ml squared t to the power minus 3. Let's see which option matches that. ml squared t to the power minus 3. That is option A. So option A is the correct answer. All right. If you need more solutions or more explanation on dimensioning of quantities, simply go check our JAMB playlist. All right. So go to playlist and look for the JAMB playlist. You'll see a video on dimensioning. It explains everything you need to know on how to dimension physical quantities. Question 14. 14 says the force between the molecules of a liquid in contact with that of a solid is A. Adhesive, B. Cohesive, C. Magnetic, D. Repulsive. All right. So what's the answer to this? For this question here, the correct answer is adhesive. All right. Now you want to know that adhesive force is simply the force between the molecules of two different substances, all right? Two different substances. In this question, they said molecules of a liquid, that's the first substance, in contact with a solid, that's a different substance. So whenever you have two different substances there, the kind of force in between each molecule is adhesive force. For instance, when you have a cup of water like this is a cup. Let's use this as a cup. Let me do this better. If you have a cup of water here, all right, so here's my cup handle, and then you have water here in this. You observe that if you pour this cup of water, let me turn this. If you turn this cup of water this way, something like this, all right, you pour out the water this way and it goes off like this. You pour the cup of water. You observe that even when you drop the cup normally, you still see some droplets of water just on the inside of the cup. All right, this is the cup here. You see water droplets just on the side, all right, of the cup. Now, this water droplet you see here is able to stick to the side of the cup because of something called an adhesive force. So, adhesive force is the force between molecules of, or is the force that holds molecules of different substances together, as explained here. All right, this is the molecule of liquid or water and the cup, that's solid. Meanwhile, cohesive force is the force that holds molecules of the same substance together. Meanwhile, for cohesive force is simply the force that holds substances of the same molecules together. All right. So if they say between a particular liquid, the force between the molecules of a particular liquid or a particular solid, that would be cohesive. All right. If they have the same substance, if they have different substances, as seen in this question, liquid and solid is adhesive. Next up, let's get to question number 15. Question 15 says an electric heating coil rated at 1 kilowatt is used to heat 2 kilograms of water for 2 minutes. The initial water temperature is 30 degrees Celsius. Take the specific heat of water as 4,000 joules per kilogram and neglect that of the container. The final temperature is A. 15.0 degrees Celsius, B. 45.0 degrees Celsius, C. 52.5 degrees Celsius, D. 60 degrees Celsius. So what's the correct answer for this question? Now, in this question, the first thing to notice is that they gave you 1 kilowatt, and kilowatt represents power. All right. So the first thing we have for question 15 is power. So question 15, the first thing we have there is power as equal to 1 kilowatt. And 1 kilowatt P is simply 1000 watts. That's the first thing I have there. Next up, let's see next we have there. They said it's used to heat 2 kilograms of water. So the mass M is equal to 2 kilograms of water, and the time T, they said for 2 minutes. All right, convert 2 minutes to second. This is simply 2 times 60. That's 120 seconds. The time there is 120 seconds. So you have this. What's next in there? They also give you the temperature, the initial water temperature. The initial temperature is 30 degrees Celsius. So let's call that T1. T1 is equal to 30 degrees Celsius. They give you specific heat of water, that's C, as 4,000 joules per kg, joules per kilogram. Right. You have to find the final temperature. Now, how do you get final temperature? That's simple. So T2, final temperature is unknown. Now, for this, you want to recall the formula for par. Par in this context is equal to work done all over time. And the formula for this would be the work done is simply mass times specific heat into change in temperature. Let me use this, change in theta all over time. This is the formula to calculate par. And this is equal to the mass times specific heat into temperature is T2 minus T1. That's a change in temperature. This all over. So for the change in temperature, we use capital T. So T2 minus T1, that's change in temperature all over time. So go back and call this capital T. So capital T1 for initial temperature, capital T2, just so that we can differentiate between the capital temperature and time. So let's make one capital T. Let's use temperature as capital T. So we have this. This is equal to, so the par from here was given at 1,000. So par 1,000 is equal to the mass. The mass is 2 kilogram as given in the question. 2 times C, specific heat of water, that's 4,000, that's C, into T2, final temperature unknown, minus initial temperature 30, T1. All right, T1 is 30 degrees Celsius, all over the time. The time is 2 minutes, which is 120 seconds. So all over 120. This is all over 1. So let's cross multiply this. This times this becomes 2 times 4,000 into T2 minus 30 is equal to this times this 120 times 1,000. All right, let's solve this. 2 times 4,000 gives you 8,000 into T2 minus 30 is equal to 120 times 1,000. That's 120,000. 120,000. Next up, divide both sides. Divide here and divide here by 8,000. Divide here by 8,000. Divide here by 8,000. This cancels this. You have T2 minus 30. It's equal to 120,000 divided by 8,000. That's about 15. To get final temperature T2, I'll simply move minus 30 over here. So it becomes 15. Minus 30 becomes plus 30. And that's equal to 45 degrees Celsius. So in essence, the final temperature T2 is equal to 45 degrees Celsius. So do we have the option there? Yep, we do. That's option B, 45.0 degrees Celsius. Okay, question number 16. 16 says an object is placed 20 centimeters from a concave mirror of focal length 10 centimeters. The linear magnification of the image produced is A, 0, B, 1 over 2, C, 1, D, 2. We have to find linear magnification. For question number 16, we know that magnification M is equal to ratio of image distance all over object distance. In this question, they said an object is placed at this distance, 20 centimeters. So we know that object distance, which is U, object distance is equal to 20 centimeters. All right, we have this value. So let's write it down. U equal to 20 centimeters. What about V? They didn't give us V, that's image distance, but they gave us the focal length. They said our focal length 10 centimeters. So I have focal length F as equal to 10 centimeters. Now with this focal length, I can get the value of V. How? Using the mirror formula. For mirror formula, we have 1 over F is equal to 1 over U plus 1 over V. Let's impute values. 1 over f. F is 10 centimeters. So I have 1 over 10 is equal to 1 over 20 plus 1 over v. Let's get the value of v from here. I'll move 1 over 20 over here. So I'll have 1 over 10 minus 1 over 20 is equal to 1 over v. Now you solve this on your own. I'll just get the final answer. All right. So use your calculator, punch 1 over 10 minus 1 over 20. Solve that, take your LCM and do your solving. You see that this will give you a value. If you solve this correctly, 1 over 10 minus 1 over 20, you have your answer as 1 all over 20. That will be your value. So if this is true, that means we can take from here, it means 1 over v is equal to 1 over 20. And if we take this upside down, we'll have that this goes up, this comes down, v over 1 is equal to this goes up, this comes down, 20 over 1, which simply means that v over 1 is same thing as v is equal to 20 over 1 is same thing as what there? 20. Of course, in cm. So it means that the image distance is actually 20 cm. So that's equal to, that means v is 20 all over, what's the object distance u? That was 20. So 20 divided by 20, that gives you 1. All right. You want to also note that magnification does not have an SI unit. So m is equal to 1. So for this question, the correct answer is C, 1. That's your answer. All right. Okay. For question number 17, 17 says the process by which protons are converted into helium atoms with a tremendous release of energy is called A. Thermionic emission, B. Nuclear fission, C. Thermonuclear fusion, D. Photoelectric emission. For this question, please take note that the correct answer is C. All right, thermonuclear fusion. So note that thermonuclear fusion is the process by which protons are converted into helium atoms with a tremendous release of energy. All right, it's called thermonuclear fusion. That's your answer. All right, next up, question number 18. 18 says a narrow beam of white light traveling in air is incident on a rectangular glass prism. The color that experiences the greatest deviation is A. Red, B. Violet, C. Blue, D. Yellow. So how do we get this? So for question 18, we know that there's something called the dispersion of white light. All right. For dispersion of white light, we have that white light breaks down to its component colors. The component colors are red, orange, yellow, green, blue, indigo, violet. So the colors are actually 7. 1, 2, 3, 4, 5, 6, 7. These are the colors you get from the dispersion of light. Now, if they ask which of them has the greatest deviation, it means starting from the first one here, that's red. Which of them is the farthest apart? Now, from red there, the one that is farthest apart is obviously the last color there, which is violet. So for this question there, the correct answer is violet. Let's see which option has violet as the option. Let's see which option has violet. Now for this, we can see that violet is option B. So option B, violet, is the correct answer. All right. So let's look at question number 19. Question 19 says, a block and tackle system has 6 pulleys. If the efficiency of the machine is 60%, determine its mechanical advantage. A, 12.0, B, 10.0, C, 3.6, D, 1.8. So how do we solve this question? Now for question number 19, you want to note that the first thing we're given there is the number of pulleys. And for a pulley system, the velocity ratio of a pulley system, VR, is equal to the number of its pulleys. All right, that's number of pulleys. And from the question, they said it had 6 pulleys. So it means that velocity ratio, VR, is equal to 6. That's the first you have there. Again, we're given the efficiency in the question there. They said the efficiency is 60, right, or 60%. So you have efficiency as being 60. You ask to find mechanical advantage. So MA is equal to unknown. How do you solve that? Recall that efficiency is equal to mechanical advantage all over velocity ratio expressed as a percentage. That means the efficiency 60 is equal to the mechanical advantage MA all over the velocity ratio, that's 6 times 100. All right, that's expressing this as a percentage. To solve this, you have this times this, right? That's, of course, this is all over 1. 60 times 6 is equal to 1 times MA. So 1 times MA times 100. 60 times 6 is 360. 360 is equal to 1 times MA times 100 is 100 MA. That's mechanical advantage. To get mechanical advantage, divide here by 100. Divide here by 100. This cancels this. So the mechanical advantage, that's MA, is equal to 360 over 100. That's 3.6. So for this particular question, the correct option is 3.6. So let's see which option has 3.6. So coming to this, you can see that the correct option there is C, 3.6. So for this question, C is the correct answer, 3.6. Finally, question 20. 20 says water of mass 150 gram at 60 degrees Celsius is added to 300 gram of water at 20 degrees Celsius, and the mixture is well stirred. Calculate the temperature of the mixture. Neglect heat losses to the surroundings. A, 60 degrees Celsius. B, 40 degrees Celsius. C, 25 degrees Celsius. D, 10 degrees Celsius. So how do we solve this particular question? Let's look at question 20. So for 20 there, the first thing we want to do is to list out the parameters that are given. All right, what and what is given in this particular question. Now for this question there, you're given two things there. You're given hot water, all right? You're also giving cool water. For the hot water there, the mass of the hot water, let's call this M1. M1 is equal to 150 gram. Also, you have the temperature at this point. So temperature, let me call this temp. That's T1. Temperature, T1, is equal to 60 degrees Celsius. All right, let's look at the cool water. For cold water, what do we have there? We have that the mass, I'll call this M2. So M2, mass of cold water, we have it as 300 grams. Okay. The temperature here too, call this temp. The temperature of the cold water, T2, is equal to 20 degrees Celsius. Of course, much lesser than that of the hot water. So you have this. Let's call the final temperature T. Let the final temperature, which we have to find, the final temperature of the mixture after stirred, let it be T, be capital T. Now, for this particular question here, the one thing you want to observe is that, so for this particular question here, you want to observe that the fluid is the same, which is water. Okay. The principle used here is that heat, because if I combine the hot water and cold water, you observe that the hot water will become colder, which means the hot water is combining with cold water, which means it will lose its heat. Meanwhile, the cold water is now getting a bit of heat from the hot water. So while the hot water is becoming colder, the cold water is becoming hotter. in essence, the principle used here is that heat loss by hot water, make all this heat loss by hot water is equal to heat gain. That's the principle we're using here. Is equal to the heat gained by cold water. All right. And of course, we are asked to neglect the heat loss to surrounding. So you can say heat lost by hot water. This is for the hot water is equal to heat gained by the cold water. Now, we know that heat Q is equal to, the formula is simply MC times change in temperature. And that's equal to MC into T2 minus T1. That's usually your change in temperature. But for this case, let's look at heat loss. The heat loss by water, let's call this Q loss by the hot water, will be equal to heat gained. So Q gained by the cold water. Now for the hot water, let's take the M. So it becomes M1, that's mass of the hot water, times C into the change in temperature for hot water becomes T1 minus T. All right. So T1 minus T. And it's T1 minus T because, of course, if the hot water is losing heat, it means the T will be a lesser value. All right. Because it will lose heat and become a lesser temperature. So it's the lesser temperature, or you subtract the lesser temperature from the greater temperature. So we have this. This is equal to, for heat gained, this is for M2, so it becomes M2 into C into, for change in temperature. Recall that for the cold water, we said it is gaining temperature. So since it is gaining temperature, it means its final temperature, which is the T, will be greater than what it had before. That's its initial T2. Would have this. Again, for this question, observe that C did not have C1 and C2. It was just C. And this is because C represents the specific heat capacity of water. And we know that specific heat capacity is a constant. Since it is a constant, C can cancel C here. And it is mathematically correct. Now with this, let's put in values. For M1, the value is 150 grams. All right. Let's impute values. That becomes 150. So 150 M1 into T1 minus T. T1 is 60 degrees, so it becomes 60 minus T. Let's write out that particular formula. That becomes 60 minus T is equal to, let's take M2. For M2, we have that as 300. That's 300 into T minus T2. What is T2? T2 is 20 degrees Celsius. So I have this as 20. Let's solve for T here. First things first, let's expand bracket. So 150 times 60, that's about 9,000. So 9,000 minus 150 times T gives you 150T is equal to 300 times T. That gives you 300T minus 300 times 20. 300 times 20 is 6,000. So you have 6,000. Now to solve this question, all we have to do is we'll take minus 6,000 over here, becomes plus 6,000. So we have 9,000 plus 6,000 is equal to, what we have here is 300T. So 300T, we'll take minus 150 over here, it becomes plus 150. So you have plus 150. So 9,000 plus 6,000 is about 15,000. So 15,000 is equal to, no, 15,000 please, not 150,000. 15,000, it's equal to 450T. 450T. 300 plus 150 is 450. Divide 15,000 by 450, your answer gives you 33.33. All right, so divide here by 450, divide here by 450. From here, this will cancel this. So T will be equal to 15,000 divided by 450. The answer there is 33.33 degrees Celsius, temperature in degrees Celsius. All right, so let's see which question has that answer. So looking at what we have here, So for this question here, the correct option should have been 33.3 degrees Celsius, all right, and not the, so the correct answer is not here. Meanwhile, take note that when solving this question here, observe that the mass was given in gram and we did not convert. If you choose to convert, which you should, convert this to kilogram, divide by 1000, it becomes 0.15 kilogram. So this should have been your solution. Also divide this mass by 1000, it would have been 0.3 kilogram. But if you choose to convert and you do this, you still arrive at the same answer, all right? Just in case you're asking, all right? I did not convert because you still have the same thing. Since we are equating them, you still have the same thing. But if you choose to still convert to kilogram before solving, you will still have the exact same answer, all right? All right, so my correct answer or the correct answer should have been 33.33 degrees Celsius, whether you use the mass as gram or in kilogram. Okay. Question 21 says, the inner diameter of a test tube can be measured accurately using A micrometer screw gauge, B pair of dividers, C meter rule, D pair of vernier caliper. Now, for this question, you want to know that inner diameters are measured using something called inside jaws. All right, something called inside jaws. And of course, the instrument with inside jaws and good precision is actually the vernier caliper. All right, so for this question there, the correct answer is D, the pair of vernier calipers, because it has inside jaws with good precision that are used to measure inner diameters. Question 22. The energy needed to move a unit positive charge around a complete electric circuit is called the A. Electromotive force, B. Electric potential difference, C. Electric energy, D. Kinetic energy. So which of these is the correct answer? For this question here, the correct answer is A. Electromotive force. All right, that's the energy needed. Now you want to take note that electromotive force is also called EMF, right? EMF or electromotive force by definition is simply electromotive force is simply the energy supplied per unit charge, right? So it's the energy supplied per unit charge. All right. So this is simply the energy needed to move a unit positive charge around a complete electrical circuit. So the answer there is the EMF. That's your correct answer. The next question there, 23, says a car traveled at a uniform speed of 100 kilometers per hour, spends 15 seconds moving from point A to point B along its route. The distance between A and B is A 50 kilometer, B 25 kilometer, C 15 kilometer, D 10 kilometer. So what's the answer to this question? Now for question 3, let's pick out the values we have there. So question 23, question 23, you're given the velocity of the movements there as 100 kilometer per hour. That's the velocity there. Again, how long did this car move there? Look at this said spends 15 seconds, right? So the time there, T is equal to 15 seconds. That's the time there. Now you're asked to find the distance, right, between A and B. How do you get distance? Now we know that distance, or we know that velocity V is equal, or speed is equal to distance all over time. That means if I cross multiply, D times 1 is equal to D. So distance D is equal to V times T. That's velocity times time, right? To get distance, I'll multiply velocity with time. So I have this. Now, the only thing here is that for velocity, as you can see, is measured in kilometer per hour, right? You can see per hour here. Meanwhile, the time is given in seconds. So all I have to do is I have to convert this velocity there. So V is equal to 100 kilometer per hour Let's convert this R here to seconds. So that's equal to 100 kilometer all over 1 hour here. Convert R to seconds. And R is simply 60 seconds. All right, so it becomes 60 seconds. This is now equal to what I have here becomes 100 all over 60. And then we have kilometer per second. Now let's get this value here. From this, V is equal to, so I'll get my calculator and punch the value of 100 over 60. All right, let's see 100 over 60. What do we have? So if you punch 100 over 60, V is equal to 1.67. That's the value in meter per second. So hence the distance D is equal to V 1.67 times T. The value of T is 15 seconds. So times 15 seconds. So that's equal to 1.67 times 15. That's about 25.05 kilometers. All right. So let's to the nearest whole number. This is 25 kilometers. All right. So I have 25 kilometers. So let's see which option is 25. All right. So the nearest whole number, this is 25 kilometers. So let's see which option is 25 kilometers. All right. So from here, you can see that B is the correct answer, 25 kilometers. 24 says to keep a vehicle moving at a constant speed V requires power P from the engine. The force provided by the engine is, you have option A, option B, option C, and option D. So how do we solve question number 24? For 24, for 24, if you look at the question back here, they mention speed, they mention power, they mention force. So let's try to relate speed, power, and force. Now the first thing we know that power is simply the rate of doing work. That's work or work done all over time. This is power. And this is equal to work done is simply force times distance. So force times distance S. That's the work done all over time. Now we know that distance over time represents velocity. That means from here, this is equal to force. All right. These two sums up to give you velocity. So times velocity. So we can say that power P is equal to force times velocity. To get the force, divide here by velocity, divide here by velocity. This cancels this. So force is equal to power all over velocity. So we have this. So let's see if we have any option as power over velocity. Yes, we do. And that is option A. That's your correct answer. All right, next up, question number 25. 25 says a solid weighs 45 Newton and 15 Newton respectively in air and water. Determine the relative density of the solid. A 0.33, B 0.50, C 1.50, D 3.00. So how do we solve this question? Now for 25, question number 25, you want to note that we can find relative density RD by taking the ratio of the weight of an object in air. So have weight in air all over, so this divided by the loss of the weight in water, right? Loss of weight in water. We know that when objects are being inserted in water, they will lose part of their weight, so they become lighter. All right. So let's get the weight in air. From the question 25 there, they said a solid weighs 45 Newton and 15 Newton respectively in air and water. So that means in air, the weight there is 45, right? Meanwhile, in water, the weight is 15. So what will be the loss in weight? Let's get the loss in weight. Loss, let's write this properly. Loss in weight. So the loss in weight will be equal to the weight in air minus weight in water, which is 45 minus 15. So how much weight was lost here? This becomes 30 Newton. So from here, we can say relative density is equal to the weight in air. The weight in air is 45 Newton all over. The loss in weight is 30 Newton. It loses 30 Newton. This will cancel this, and that's equal to 45 divided by 30. That's about 1.5. So the relative density is actually 1.5. It has no SI unit. So the answer there is 1.5, which is option C, 1.50. All right, next up, question number 26. Question 26 says the kinetic energy of a photoelectron liberated from a metallic surface depends on the A. Intensity of the incident radiation. B. Time duration of the incident radiation. C. Temperature of the incident radiation. D. Frequency of the incident radiation. So which of this is the correct answer? Now you want to take note that the kinetic energy of a photoelectron, the formula from Einstein's photoelectric equation, all right? From Einstein's photoelectric equation, the kinetic energy of a photoelectron is given by Ke, especially the mass kinetic energy, is equal to Hf minus phi, where H represents the Planck's constant, F represents the frequency, and phi represents work function. So it depends on Planck's constant, well, this is actually constant, frequency, and then work function, which is phi. So let's see if you have frequency or work function as part of the options. So for 26, we have, looking at this, we can see that the option is D, all right? Frequency, that's correct. So from the formula, we could see that it depends on frequency. Look at this here, which is this F here. That's the frequency. So yes, the frequency of the incident radiation. That is the correct answer. Next up, question 27. 27 says a screw jack has a pitch of 0.5 centimeters and a tummy bar of length 20 centimeters. The velocity ratio is A, 40 pi, B, 40 over pi, C, 80 pi, D, 80 over pi. So which of these is the correct answer? Or how do we solve this particular question? What do we do? Now for this question here, you want to note that for a screw jack, all right, the instrument here is a screw jack, 27, for a screw jack, so for a screw jack, you want to note that the velocity ratio is given by distance moved by 1 ton, all right, distance moved by or moved in 1 ton, moved in 1 turn, this all over, so all divided by the pitch. All right. So from this also, distance moved in 1 ton, let's call it D. The formula for this is actually 2 pi r, and that's equal to 2 times pi times, what's the value of r? The r there is simply the length, all right? Now looking at this, you can see that pitch is given in centimeters and length in centimeters. If you choose to convert them to meters, it will still be the same thing as if you don't convert, because you're having cm at numerator and cm at denominator, so they will cancel out, all right? So if you want to convert them to meter first, you're free to do it, or if you don't want to, you could leave it out. Since you have centimeters at numerator and denominator, they will cancel out. For me, I will not convert. I'll just go straight. So the length here, right? The length of the tummy bar is equal to its radius. So please take note, right? For a tummy bar, its length is equal to its radius. That means the radius there becomes 20 centimeters. Again, if you want to convert to meters, you will have the same answer. So 2 pi times 20, 2 times 20 gives you 40 pi centimeter. This is the distance moved in 1 turn. What's the pitch? The pitch is equal to, from the question, they said the pitch is 0.5 centimeters. So pitch there is 0.5 centimeters. So from here, velocity ratio is equal to Distance moved in one turn is 40 pi centimeter all over pitch 0.5 centimeters. Looking at this, you can see that centimeters will cancel centimeters, and this was what I was trying to tell you. All right, so even if you choose to convert it, even if you choose to convert, you'd have the same answer. So that's equal to 40 divided by 0.5. The answer becomes 80. All right, 40 divided by 0.5, that gives you 80. Bring back the pi, so you have 80 pi. So the correct answer to this question is 80 pi, which is option C. 80 pi is your correct answer. All right, next up, question number 28. 28 says the photoelectric cell works on the principle of the A. Voltaic cell, B. Emission of electrons by incident radiation, C. Emission of protons by incident radiation, D. Photographic plate. So for 28, what's the correct answer here? Now, you want to know that for this question, the photoelectric cell works on the principle of photoelectric effect. All right, it's photoelectric effect. And photoelectric effect is simply the emission of electrons by incident radiation. So for this particular question there, the correct option is B, which is the emission of electron by incident radiation, which is known as the photoelectric effect. Let's look at question 29 and 30. Question 29 says, what flows to the earth by connecting the conductor to the earth? A. Electrons. B. Ions. C. Neutrons. D. Protons. So this should be protons. All right. Now, for this, you want to know that when it comes to subatomic particles, electrons, protons, and neutrons, the only subatomic particle that actually flows or move is the electrons, right? Neutrons do not flow, protons do not flow, right? The correct one there should be electrons, right? Electron is the subatomic particle that actually flows, all right? All right, let's look at the last question there. Question number 30. Question 30 says, if the focal length of a camera is 20 centimeters, the distance from the film at which the lens must be set to produce a sharp image of 10 centimeter away is A. 17 cm, B. 20 cm, C. 25 cm, D. 100 cm. Now, in this question, they said the focal length of the camera is 20 centimeters. So they've given you focal length. They said to produce a sharp image of 100 centimeters away. They've given you the image distance. So you've been given focal length 20 centimeters. You've been given the image distance 100 centimeters. You're asked to find the distance from the film at which the lens, which is the object. So you're asked to find the object distance here. All right. So let's get that. For question 30, let's use the mirror formula. All right. Let's use the mirror formula. For mirror formula, you have 1 over f is equal to 1 over u plus 1 over v. All right, we have to find the object distance, which is the lens distance. So we're going to find this one here, u. And to do that, we'll move 1 over v over here. So it means I will have 1 over f minus 1 over v is equal to 1 over u. That becomes 1 over u. Let's impute values. That becomes 1 all over f. The value of f is 20 minus 1 over v. The value of v, which is the image distance, right? The image distance was given as 100, which is equal to 1 all over u. All right, let's solve this question here. From here, my LCM 120, right? The LCM here is 100. So 100 divided by 20 is 5. 5 times numerator, 5 times 1 is 5. So I have 5 there. 5 minus 100 divided by 100 is actually 1. 1 times numerator, that's 1, is equal to 1 all over the object distance. Proceeding, this is equal to 5 minus 1 numerator is 4 all over 100 is equal to 1 all over u. From here, Of course, this can be broken down 4 here, 1, 4 here, 25. All right, so you have 1 all over 25 is equal to 1 all over u. So with this, all you have to do is take this one upwards and take this downwards. So that becomes 25 all over 1 is equal to take u upwards and take 1 downwards. That becomes u all over 1. From this, what we'll have here is simply 25 over 1 gives you 25 is equal to u over 1 gives you u. So of course, it's in cm, so u is equal to 25 cm. So the distance at which the length must be kept should be 25 cm. That is the correct answer. So for this question, let's see. That is option C, 25 centimeters. So that is the correct answer. Question 31 says, a particle of mass m initially at rest splits into two. If one of the particles of mass m1 moves with velocity v1, the second particle, that should be of mass m2, moves with the velocity. You have option A, option B, option C, and option D. Now, for this question here, you're asked to find the velocity of the second particle. Now, let's analyze this question. For question 31, right, they said a particle of mass m initially at rest. Let's call the velocity of this mass m, let's call it v, right? We'll call it v. They said this splits into two particles. The two particles have masses m1, of course, whose velocity will be v1. And they said the second mass is m2. You're asked to find the value of v2. So its own mass v2 is equal to unknown. Now, how do we solve this question? For this question, we'll use the concept of the conservation of momentum. All right. The first particle has a mass m. This m splits into two different particles, m1 and m2. That means the mass m will be equal to m1 plus m2. That means if I combine these two masses, I will have my initial mass m. From here, we can get that m2 is equal to, from here, let's get the value of m2, move m1 over here. We can have that m minus m1 is equal to m2. So let's keep this pending. Now, here's the first thing we have there. Also, let's use conservation of momentum. All right. Initially, they said the particle was at rest. So if we take this first condition here, it becomes the initial mass m times the velocity v will be equal to the final momentum will be the first mass m1 multiplying its velocity v1 plus the second mass m2 multiplying its own velocity v2. So we have this. Now with this, let's impute values. We have m times the value of v, velocity. They said initially the particle m was at rest before it split. So if it's at rest, it means its own velocity is 0. This is equal to, we have m1, so I have m1 here, times v1. So m1 v1 plus m2. We are going to express m2 because we don't want to bring in too many variables. We already have m and m1. So let's just maintain our two variables, m and m1, or two unknowns. And to do that, we can express m2 in terms of m and m1 by saying m2 is the same thing as saying m minus m1. With this, we now have only two unknowns, m and m1. As you can see here. So we've replaced m2 we've replaced m2 with m minus m1 into v2. So we now have v2 here. And don't forget, we asked to find v2. All right, v2. All right, so from here, what I'll do next is that I'll move m1. All right, at this point, multiplying through, this becomes 0 is equal to m1 v1 plus m minus m1. So you have this into v2. Now to get the value of v2, move this one over here. All right, move this over here. It becomes negative minus m1 v1 is equal to, I'm left with m minus M1 into V2. Divide here by M minus M1. Divide here by M minus M1. So this will cancel this. So V2 is simply minus M1 V1 all over M minus V1. Now for this, you want to take note that negative here, when it comes to the concept of momentum, negative simply represents direction. All right. So negative only represents direction. So in essence, we can say that V or V2 is equal to M1 V1 all over M minus M1. All right. I said I'm taking off the negative because the negative here doesn't really have an effect on the value. It only represents direction. It means that V2 being negative means that M2 is moving in the opposite direction. That's what it means. So the correct answer is M1 V1 all over M minus M1. Let's see which option has this value. All right, so looking at the options there, the correct answer is A, M1 V1 all over M minus M1. That's your correct answer. All right, question number 32 says a room is heated by means of a charcoal fire. An occupant of the room standing away from the fire is warmed mainly by A. Convection, B. Radiation, C. Conduction, D. Reflection. Now, you want to know that for this question, that charcoal fire emits infrared radiation, all right, which travels through air. In essence, for this question, note that conduction requires contact. For you to travel via conduction, contact is needed. Meanwhile, convection heats air, not distance people. So for this question there, the correct answer is B, radiation. Okay? Because charcoal fire emits infrared radiation. So the correct answer there is radiation. Question number 33. 33 says, a resistor connected to a 12-volt battery draws a current of 2 amperes. The energy dispatched in the resistor in 5 minutes is A. 3,600 joules, B. 6,000 joules, C. 7,200 joules, D. 14,400 joules. Now, how do we solve this question? In this question, we are asked to find energy, 33. So for question number 33, we are asked to find energy. All right. And what we know as regards power is that power, okay, energy is equal to unknown, but we know that power is equal to electrical energy all over time, or work done over time. All right. So we can get energy E by cross multiplying power times time. So it becomes power times time. So energy is power times time. Also, power is equal to, if I'm given the voltage and current, power is simply voltage times current. If I substitute this here, it means that energy is equal to, in place of power, I'll put voltage times current and then bring in the T, so times time. It means that electrical energy is equal to, the voltage as given in the question was 12 volts, so 12 times the current was 2 amperes, so 2 times the time was 5 minutes. All right, convert 5 minutes to seconds, it becomes 5 times 60. Now 5 times 60 is converting the time from minutes to seconds. From here, my final answer is equal to, let's punch this value. So we'll be having 12 times 2 times 5 times 60. If you punch this, your correct answer is 7,200 joules. So the energy is 7,200 joules. All right, let's see which option that is. That is option C, 7,200 joules. That's your answer. All right, next up, question number 34. 34 says, the image of an object is located 6 cm behind a convex mirror. If its magnification is 0.6, calculate the focal length of the mirror. Option A, 0.37 centimeters, B, 6.70 centimeters, C, 10.00 centimeters, D, 15.00 centimeters. All right, so how do we solve this particular question? Now, First is first. For this question, they said they give us magnification 34. All right. For 34, we are given magnification m, and the value is equal to the said 0.6. All right. So I have 0.6. Next to the said the image of an object is located 6 cm behind. So image distance, that's v, is equal to 6 cm behind the convex mirror. Okay, they give us back. They said calculate the focal length of the mirror. The focal length f is equal to unknown. Now we know that m, which is the magnification, m is equal to v all over u. That is image distance all over object distance. The value of m is 0.6. So we have that 0.6 is equal to v, which is 6 all over u. So let's get the value of u. This is all over 1, and that will give you 0.6 times u gives you 0.6 u is equal to 6 times 1 gives you 6. To get u, divide here by 0.6. To get u, divide here by 0.6. This cancels this. So u is equal to 6 over 0.6, and that's about 10. Of course, in centimeters. So we've gotten u as 10. Let's get the focal length. Using mirror formula, we know that 1 over f is equal to 1 over u plus 1 over v. 1 over v, and that's equal to 1 over u. 1 over u is 10 plus 1 over v. V is 6, so all over 6. So we have this. Let's sum this up. This is equal to my LCM here is 60. 60 divided by 10 gives you 6. 6 times 1 gives you 6. So I have this as 6 plus 60 divided by 6 gives you 10. 10 times 1 is 10. So this plus 10, we have this. So 1 over f is equal to this. 6 plus 10 is 16 all over 60. Okay, so from here, cross multiplying, we'll have, okay, before then, 1 over f is equal to 16 over 60. From here, if you cross multiply, 16 times f gives you 16f, all right? 1 times 60 gives you 60. To get the value of f, divide here and divide here by 16 by 16. This cancels this. The focal length f is equal to 60 over 16. That's 3.75. That's 3.75. This would be in centimeters. All right. So let's see which option matches that. So 3.75, that is option A, 3.75. All right. Next up, let's look at the next option there. Next question there. Question 35. It says a 40-watt instrument has a resistance 19 ohms. On what voltage should it be operated normally? A, 60 volts, B, 150 volts, C, 225 volts, D, 360 volts. All right. They give you the part there as 40 watts. They give you resistance as 9 ohms. You're asked to find voltage. Now we know that for question number 35, we know that power P in terms of voltage and resistance is simply V squared over R. So you're asked to find the voltage that it should be operated on. The power was 40, so we have power 40 is equal to V squared all over. They give you resistance in that question as 90 ohms. All right, so let's solve this question. From here, this would be equal to this all over 1. V squared times 1 gives you V squared is equal to 40 times 90. 40 times 90. So I have V squared is equal to 40 times 90. That's 3,600. From here, V is equal to the square root of 3,600, and that's about 60 volts. So V is 60 volts. So let's see which option matches that. So the correct answer there is A, 60 volts. Next up, question number 36. 36 says, which of the following phenomena is the practical evidence of the existence of the continual motion of molecules? A. Transitional movement motion. B. Rotational motion. C. Brownian motion. D. Oscillatory motion. For this question here, the correct answer is simply Brownian motion. All right. Brownian motion is one of the evidence of the existence of the continual motion of molecules. Question 37. 37 says palm oil from a bottle flows out more easily after it has been heated because the A molecules are given energy during the heating, B friction between oil layers is reduced, C oil molecule force oil molecules force each other out, D adhesion between the oil molecules and those of the bottle is increased. So which of this is the correct answer? Now you want to note that there's something called viscosity, all right? Something called viscosity, all right? Now, the reason why palm oil flows out sluggishly from its container is because of something called viscosity. And viscosity is simply the frictional force that exists between the layers of a fluid in motion or the layers of a liquid in motion. In essence, the reason why palm oil flows out sluggishly is because friction is being formed between its layers. And for the frictional force to be broken or reduced, what we have to do is that we now heat the bottle or the container containing the oil. In essence, heating the container containing the palm oil would help to reduce the friction or the viscosity. So for this question here, the correct answer is B. All right, friction between the oil layers is reduced. All right, so when the friction between the oil layers is reduced, oil now flows out more easily, right, or faster. So when the friction is reduced, oil flows out easily, all right, or faster. All right. Question number 38. 38 says a pulley system has three pulleys in the fixed block and two in the movable block. And if the pulley has an efficiency of 72%, the mechanical advantage of the system is A 36.0, B 7.2, C 5.0, D 3.6. All right, so how do we solve this particular question? Now, for a pulley system, 38, for pulley system, for a pulley system, you want to note that the velocity ratio VR is equal to the sum of movable pulley and fixed pulley. So it becomes fixed pulleys plus movable pulleys. That's how we get the velocity ratio. All right, and that's equal to how many fixed pulleys do we have here? We said has three pulleys in the fixed block and two in movable. So it becomes 3 plus 2. That becomes 3 plus 2, and that's equal to 5. Of course, it has no SI unit, so velocity ratio is 5. Okay. Now they said it has an efficiency of 72%. So efficiency, this is equal to 72. You're asked to find the mechanical advantage. So MA is equal to unknown. All right. So how do we get this? So you want to record that efficiency, or they gave you this as percentage if you want to. Let's go back and put percentage here. So efficiency is equal to 72%, which is equal to 72 all over 100. That's 72%. And this is 0.72. Okay. So efficiency is equal to mechanical advantage all over velocity ratio. So from here, this value 0.72 is equal to mechanical advantage all over VR is 5. This is all over 1. From here, this times 1, mechanical advantage times 1 is mechanical advantage is equal to this times this 0.72 times 5. From here, we have 0.72 times 5. That's about 3.6. All right. It has no SI unit. The mechanical advantage for this question is 3.6. That's your correct answer. For this question, the correct option is D, 3.6. All right. Question 39. 39 says, which of the following concept is not an evidence, all right, not an evidence of the particle's nature of matter? A, diffusion. B, Brownian motion. C, diffraction. D, crystallization. All right. So for this question here, you want to note that diffusion is an evidence of the particle nature of matter. That means matter contains particle. Brownian motion is another evidence of the particulate nature or the particle nature of matter. Crystallization is also another evidence of the particle nature of matter, but diffraction is not. All right. By diffraction is simply the bending of light rays or waves. All right. It's a wave phenomenon. Right. When light rays get to a particular corner, it bends. That's the concept of diffraction. So in essence, diffraction is only a wave phenomenon and it is not an evidence of particle nature of matter. So the correct option is C. All right, question 40, our last question for this video. All right, so question 40. Question 40 says, an inclined plane which makes an angle of 30 degrees with the horizontal has velocity ratio of A 2, B 1, C 0.866, D 0.5. So how do we solve this question? Now, for question number 40, you want to note that for inclined plane, its velocity ratio is equal to the inverse of sine of the angle of inclination. That's it. And that's equal to inverse of sine of, what's the angle of inclination? Theta. From here, the value of theta is 30 degrees, right? So this all over sine theta is 30. And that's equal to, let's punch 1 over sine 30. If you punch 1 over sine 30, the correct answer there is 2. So you have 2 there. So the velocity ratio is 2. It has no SI unit. So let's look at the option there. From this, the correct option is A, 2. So you have this. Question 41 says, a man hears his echo from a nearby hill 2 seconds after he shouted. If the frequency of his voice is 260 Hz and the wavelength is 1.29 meters, how far away is the hill? A, 330.0 meters, B, 335.4 meters, C, 660.0 meters, D, 670.8 meters. So how do we solve this question? Now, in this question, the first thing you want to observe is that you're given time t as 2 seconds. So for 41, you're given time t as equal to 2 seconds. Also, they said if the frequency of his voice is 260 hertz, so you're given the frequency of his voice, so small f, frequency as equal to 260 hertz. Also, they said, and the wavelength is 1.29 meters. So you have wavelength lambda as equal to 1.29 meters. You have this. You're asked to find how far away is the hill, which is your distance. So distance is equal to unknown. Now, how do you solve this question? For this question here, the first thing we want to get is the velocity of the sound. And how do we find that? Recall that velocity v is equal to frequency times lambda, all right? That's wavelength. And that will be equal to frequency is 260. 260 times lambda, the wavelength is 1.29. So let's multiply this. So if you multiply this, this will be equal to 260 times 1.29 gives you about 335.4, of course, in meters per second. So we have this. All right, so we have this question here. Again, looking at this question here, they said A man hears his echo from a nearby hill 2 seconds after he shouted. So let's consider the concept of echo. If the man stands here, right, and shouts, which creates an echo, such that the echo comes after there's a hill. Let's call this a hill here. Let's call this hill. All right. If the man hears his echo 2 seconds after, it means the sound wave travels from the man to the hill in 1 second and then travels back in another second. So in total, he hears the sound that is being reflected after 2 seconds. So what does this mean? It means that the time the sound wave travels from the man to the hill is actually 1 second. All right. 2 seconds is all the time it takes for the sound to hit the hill and then come back to the man. In other words, the t, 2 seconds, is the time for the round trip. Meanwhile, the one-way time, right? One-way time, that's t. Let's call this t for one trip. All right, so I'll call it t1 is equal to 1 second. So we have this. So in essence, we can get the distance. All right, the distance, let's call this d, as we know, is equal to velocity times time. And that's equal to, so the distance between the man and the hill, that's from point, let's call this A, from point A to point B. Distance between the man and the hill is simply the velocity, which we've got as 335.4 multiplied by the time it takes for the sound wave to leave the man and hit the hill, which is just for one time trip. All right, which is, or we call it one-way time, which is actually 1 second and not the total time, 2 seconds. So this times, that's t1, which is equal to this times 1. All right, we use the time for just the one-way time. So 335 times 1, that will be equal to, so this is equal to 335.4 meters. So this becomes the correct answer. All right. So this gives you the distance between the man and the hill. All right. So you want to take note that the major concept in this question is that these 2 seconds given is the time it takes for the sound wave to leave the man, hit the hill, and then come back to the man, which is 2 seconds. Meanwhile, the time it takes for the echo or the sound wave to leave the man and get to the hills is actually 1 second. So if you're to calculate the distance between the man and the hill, you're supposed to use the time in which the sound wave travels from the man to the hill. All right, you're not supposed to add and back. So we'll be using 1 second, not 2 seconds. So that's the simple concept. Multiply, get your velocity, which is what we did here. Multiply frequency times wavelength, which is what we did here, and then use the time from the man to the hill, which is actually 1 second. That's half of total time. So this times 1 gives you 335.4 meters. So that's your correct answer. So for this question, the correct answer is B, 335.4 meters. All right, question number 42. 42 says a lens of focal length 15 cm forms, this would be an erect image. All right, so forms an erect image which is 3 times the size of the object. The distance between the object and the image is dash. A, 10 centimeter, B, 20 centimeter, C, 30 centimeter, D, 40 centimeter. So how do we answer this question? Now for this question, they said, first they said a length of focal length. You're given focal length F as 15 cm. 42, the focal length F is equal to 15 cm, that's 15 in centimeters. That's the first in there. Next up, they said forms an erect image, which is 3 times the size of the object. So the image size, we know that image distance V or image size is equal to 3 times that of the object. So we're saying that V is equal to 3U. That's it, all right? Image size or image distance is equal to 3 times the object distance. So we have this. Next, they said the distance between the object and image is, so all we have to do is to get the object distance, get the image distance, and then we can solve this question. All right. And how do we do that? Using the mirror formula, we know that 1 over F is equal to 1 over U plus 1 over V. and that would be 1 over F. F is 15, is equal to 1 all over U plus V is 3 over V is 3U. That becomes 1 all over V is 3U. Let's solve this particular question here, or this equation. We'll have 1 over 15 is equal to, for this question, the LCM of U and 3U, that's this and this, the LCM is actually 3U. So we'll have the LCM as 3U, all right? 3U divided by U gives you 3. 3 times numerator, that's 3 times 1, gives you 3, plus 3U divided by 3U, that gives you 1. 1 times numerator, 1 times 1 gives you 1. From here, would have that 1 over 15 is equal to 3 plus 1, that's 4. 4 all over what's there? 3u. Let's get the value of u, cross multiply. 3u times 1 gives you 3u. So 3u is equal to 4 times 15. 4 times 15 is actually 60. So with this, we can get the value of u divided by 3, divided by 3. We'll have that u is actually 20 in centimeters. Of course, this cancels this, this cancels this. We have 20 centimeters. But v is equal to 3u. That becomes 3 times 20, and that's equal to 60 centimeters. In the question, you're asked to find distance between the image and the object. Now, to get the distance between the object and the image, we'll have that distance d is equal to v minus u, right? And we're using v minus u since that's both the image and the object are on the same side of the lens, because in this particular question, a virtual image is being formed, all right? And that will be equal to 60 minus 20. 60 minus 20 gives you 40 centimeters. So for this question, the correct answer is 40 centimeters. That is option D. Next up, question 43. 43 says, which of the following pairs of color gives the wildest separation in the spectrum of white light? A, red and violet. B, green and yellow. C, red and indigo. D, yellow and green. Now for 43, if you look at the spectrum of white light, that's 43. In the spectrum of white light, when you have white light, so let's say this as white light. When you have white light being broken down into 7 colors: red, orange, yellow, green, blue, indigo, and violet. For this color, the one with the highest separation would be red, that's the first one, and then violet, that's the last one. So this has the widest separation. So the correct answer there is red and violet. Let's see which option has red and violet. That is option A, red and violet. So that's your answer. Question 44. For what values of F and theta will the forces shown in the diagram below be in equilibrium? For this question, we don't really have a diagram for this, so just keep 44, right? Let's just keep it since we don't have a diagram for this. So skip this, move to the next question there. Question 45. 45 says an object weighs 30 Newton in air and 21 Newton in water. The weight of the object when completely immersed in a liquid of relative density 1.4 is dash. A, 25.2 Newton. B, 17.4 Newton. C, 12.6 Newton. D, 9.0 Newton. That's what we have. All right, so how do we solve this question? Now, for question number 45, the first thing we have there is weight in air. So I'll call this weight in air. The value there is 30 Newton as given. Next, they give us the apparent weight. All right. The apparent weight is simply the weight in water, which is 21 Newton. So I'll call this weight in water. The value there is 21 Newton. What next do we have here? Now, with these two, we can find the upthrust or the loss in weight in water. So upthrust in water, I'll call this UW. So UW is simply upthrust in water. That value is simply weight in air. So weight in air. minus weight in, let's use W for water, all right? And that's equal to 30 minus 21. 30 minus 21, the answer there is 9 Newton. This is the loss of weight in water, or the upthrust in water. Okay, next up, they said we should find, or the next thing to find here is the upthrust in the liquid. All right, let's get upthrust in the liquid. So upthrust in the liquid. By in the liquid, we mean this other liquid here. All right, this liquid here, whose relative density is 1.4. And how do we get that? Now you can get the upthrust in any liquid. Let's call this UL. The upthrust in liquid is equal to the relative density of that liquid. Let's call it RD of the liquid times the upthrust in water. All right, so times the upthrust in water. With this, you can always get the upthrust in any liquid. Just multiply the relative density of that liquid times the upthrust in water, and that will be equal to the relative density of the liquid as given in the question is 1.4. So 1.4 multiplied by the upthrust in the liquid is given by 9. The upthrust in water is actually 9. All right, so we have 1.4 times 9. And if you do that, your value there is 12.6 Newton. So we have this. All right, so with this, we've gotten the upthrust in the liquid. Now, finally, let's now get the apparent weight in that liquid. All right, so that's what the question asks us to find. The weight of the object when completely immersed in the liquid. A liquid, that is simply the apparent weight in that liquid. So the apparent weight in the liquid, the apparent weight in liquid, to get that, that will be equal to the true weight, or the weight in air, minus the upthrust in the liquid. All right, and that's equal to the weight in air is 30 minus the upthrust in the liquid. We got the value as 12.6. So minus 12.6. 30 minus 12.6 gives you 17.4 Newton. So that's your answer. So let's see which option is 17.4 Newton. That is option B, 17.4 Newton. So that's the correct answer. Next up, question 46. 46 says a beam of light is incident from air to water at an angle of 30 degrees. Find the angle of refraction if the refractive index of water is 4/3. A, 15 degrees, B, 18 degrees, C, 22 degrees, D, 24 degrees. So how do we solve this question here? Now, for this question, they said a beam of light is incident from air to water at an angle of 30 degrees. So 46, they gave us the angle of incidence I as equal to 30 degrees. That's your value. They said find the angle of refraction. So angle of refraction, small r, is equal to unknown. They said the refractive index of water, so N of water, that's N is equal to 4/3. How do we solve this question? For this question, we have to use Snell's law. For Snell's law, we know that the refractive index N is equal to sine of the angle of incidence all over sine of the angle of refraction. From this, N is 4/3. So 4/3 is equal to sine I all over sine R. In solving this, let's cross multiply. 4 times sine R gives you 4 sine, 4 sine R is equal to 3 times sine I gives you 3 sine I. You have this. All right. Next up, divide here by 4, divide here by 4. So this cancels this. You have that sine R, sine of R is equal to 3 sine I over 4. Let's put in values. We'll have that sine R is equal to 3 sine I. What's the value of I? I is 30. So it becomes this sine 30 all over 4. And that's equal to, let's put in values, 3 sine 30 all over 4. The value there is 0.375. To get R, I'll simply take sine inverse. So R becomes sine inverse of 0.375, and that's equal to sine inverse of 0.375. That's about 22 in the nearest whole number is 22 degrees, right? That's your nearest whole number. So let's see our answer, 22 degrees. Do we have the option there? Yep, that's option C, 22 degrees. That's your answer. All right, question 47. 47 says an electric iron is rated at 1100 watts, 220 volts. The iron's resistance and current it draws are, you have option A, option B, option C, and option D. So how do we solve this question? For question 47, the first thing you want to notice that power, or recall, is that power is equal to the square of velocity all over resistance. From here, if you're to get the value of R, this is all over 1. If I cross multiply P times R, that gives you power times resistance is equal to, that gives you power times resistance is equal to V squared times 1 gives you V squared. You have this. So to get resistance, divide here by power, divide here by power. So from here, the resistance R is equal to V squared all over P. And that's equal to V, voltage, 220 volts. So that becomes 220, that's a volt, all squared, all over the power. The power is 1100, and that's equal to, let's put in values, 220 squared is 48,400. That's 48,400 all over 1100. All right, divide this by 1100, that's 44. So this is 44. Resistance is in ohms. It becomes 44 ohms. We've gotten resistance. Now let's get current. Again, recall that power is equal to current times voltage. In essence, to get current, I'll divide here by voltage, divide here by voltage. This cancels this. So that means that current I is equal to power over voltage. And that's equal to, the value of the power there, it's 1100. That becomes 1100 all over, the voltage value is 220. So this all over 220. 1100 over 220, that's 5. All right, so 5 amperes. So for this question, the resistance is 44 ohms. The current is 5 amperes. 44 ohms, 5 amperes. That is option B. So option B is your correct answer. Okay, question 48. 48 says the efficiency of energy conservation on the energy flow through a hydroelectric power is, you have option A, option B, option C, and option D. So which of this is the correct answer? Now for this question, you want to note that the energy flow in a hydroelectric power station, the typical sequence is given by, for 48, the typical sequence of the energy flow in a hydroelectric power station is given by E1, where E1 would represent gravitational potential energy of water. All right, call this gravitational PE, potential energy of water. All right, and this is for the input. E2 would represent mechanical energy of the turbine. So mechanical energy of the turbine, write this here, of turbine. E3 would represent the electrical energy. So electrical energy produced. And this is literally your output, all right, or useful output. So we have this. Now, when it comes to efficiency, for efficiency, We know that efficiency, this is simply the ratio of the useful output energy, right? So output energy all over the input energy. So all over the input energy. The output energy, as we can see, is the electrical energy, which is E3. So it becomes E3 all over the input energy, which is the gravitational potential energy of water, which we call the input energy, and that's equal to E1. So it becomes E3 over E1. All right, so let's compare these to our answers. All right, so we have E3 over E1 as the efficiency. Let's compare this to our answers. Now, comparing this to our answers, the A part says E2 over E1. Now, you want to note that E2 over E1 here represents the efficiency of the turbine only. This is for the turbine only. This is for the turbine only. Turbine only. Meanwhile, option B, E3 over E2, this one here represents the efficiency of the generator only. All right, generator only. E3 divided by E1 plus E2. What you have here is not physically correct. So this one is not even possible. And of course, D, which says E2 plus E3, all divided by E1, is not even a valid efficiency expression. So the only valid ones are A and B. Now, in JAMB convention, when asked about the efficiency of energy conversion through the hydroelectric power station, the closest and the correct representation provided is for the turbine stage only. All right. So since it's for the turbine stage, this is what is closest to the actual efficiency, which is actually E3 over E1, as you can see here. So because of this reason, we'll take A as the correct answer. All right. So we'll just work with the turbine efficiency only. All right. This is the closest representation to the actual efficiency of the system. All right. Next up, question 49. So let's get for 49 here. Question 49 says mercury, which is spilled onto a glass surface, forms ball-like shape because you have option A, B, C, and D. Now, here's what to know. If you have a surface like this, all right, let's call this a glass surface as mentioned in the question, and you spill mercury on this. Now, mercury being a liquid, you think it would pour throughout the surface, but no. Mercury literally forms something like a ball, as said in the question, something like this. So you have mercury like this, something like a ball here, right? It forms something like this. Now, the reason why you have something like this or why mercury forms this way is because for mercury here, the force between the molecules of mercury, which is called the cohesive force, all right? It is the force that exists between the molecules of mercury is greater than the adhesive force. There's a force that connects this mercury and the surface. So there's a force here that tends to stick this mercury and the surface. That's called the adhesive force. Now, the reason why mercury forms this shape is because the cohesive force is greater than the adhesive force. That's it. So we can say the cohesive force between the molecules of the mercury, right, or of mercury is greater than the adhesive force between mercury and the surface. So let's see what option that is. All right, that's option B. All right, option B, that is the cohesive force between its molecules, that's the mercury molecules, is greater than the adhesive force between mercury and the glass molecules. So yes, B is the correct answer. All right, next up, final question here, question number 50. So for question 50, they said, which of the following phenomena cannot be explained by the molecular theory of matter? A, conduction, B, convection, C, expansion, D, radiation. All right. Now, what to note is this. The molecular or the kinetic theory of matter explains phenomena that arise from the motion and interaction of particles, either molecules or atoms. Let's take the options one after the other. Option A is conduction. Now, heat transfer by conduction, or in conduction, heat is transferred by the vibration and the collision of particles. So hence, this can be used to explain the phenomenon of the molecular theory of matter, because the vibration or the collision of particles is involved. So A cannot be the correct answer. Let's go to B, convection. Now, for convection is simply heat transfer by bulk motion of fluid particles. So since fluid particles have to move, this can be used to explain the molecular theory of matter. That means matter has molecules. Let's look at the third one there, expansion. Now, expansion occurs because particles move faster and farther apart when heated. So since particles move faster and farther apart when heated, we can use expansion to explain the phenomenon of the molecular theory of matter. Now, next up, radiation. In radiation, heat transfer is by electromagnetic waves, all right? It does not require matter or molecules. So for this, it is actually radiation, all right? So radiation cannot be used to explain the molecular theory of matter, since matter is all, since molecules of matter are not used during radiation. Instead, it is simply heat transfer by electromagnetic waves. Okay. All right, guys. So we are now done with all the questions in the JAMB Physics 2023 set of questions. All right. If you enjoyed this video, don't forget to hit the like button. All right, like this video. Don't forget to also leave a comment. So if you enjoyed this video, tell us you enjoyed this video in the comment section. If you have any questions, leave the questions in the comment section and I'll get to you. If you're yet to subscribe, please do well to subscribe to this channel, hit the bell icon and select all so that you get notified when we upload a new content. Don't forget to also follow this channel on revision for JAMB Physics questions, JAMB Chemistry questions, JAMB Mathematics questions, and JAMB Biology questions. See you in our next class. We have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMBites, or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right, for the comments, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon, and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class. Okay, guys, so please take note that we have a JAMB WhatsApp group for JAMBites. All right. So if you're writing JAMB, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMBites, or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comments, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.